Okay, hello everyone. Today's topic is spherical mirror. There are two types of spherical mirror. One is concave mirror, another is convex mirror. So concave and convex mirror. So first of all, you need to know how they can be differentiated, right? So first thing is that concave mirror, this is a kind of a sphere, means side part of sphere, that's why it is called spherical mirror or curved mirror, right? And outside part there is a reflecting coating is there. In case of concave mirror, it is basically lead oxide, the red color, right, is the reflecting coating or the silver coating is outside, and inside there is a reflection occurs. So reflection occurs inside. Okay, remember that reflection of light is done inside of a concave mirror. And in case of convex mirror, the inner part is there is a reflecting coating in the inner part, okay, and the reflection occurs in the outer part of the light. So this is the reflection occurs in the outer part of it, right? Concave mirror is basically is also called converging mirror, right? And this is called diverging mirror. This is okay. So it is converging mirror, it is diverging mirror. Now let me show you one by one the properties. First of all, for both cases, let me show you. This is A B. This A B, A to B, where reflection occurs. This part is called aperture of the mirror. Aperture of the mirror. So AB is the aperture for both cases. Now if it is a curved mirror, if we consider this is a part of a sphere, so if we complete the sphere by imagination, if we complete the sphere, every sphere must have a center. Every sphere must have a center, right? That center point is denoted as C. This is C. Here also same. If we complete this circle, this is not circle, actually sphere, this every sphere must have a center. This is called C, center of curvature, right? So this C is basically the center of curvature. Center of curvature. The midpoint of the aperture, the middle point of the aperture is P, denoted as P. Here also same in case of convex mirror, P. So this P is basically the pole. Another name, pole. Pole, every object distance, image distance, focal length, whatever in case of concave mirror or convex mirror, always has to be taken from the pole. So pole is basically taken as a reference point. Taken as a reference point. So this is pole. Now if we draw an imaginary line, horizontal line, which connected the center of curvature and pole, and this is horizontal imaginary line, this line is called principal axis. Here also same, pole and center of curvature, if you join them with a horizontal imaginary line, this is called principal axis. So this line, the name of this line is principal axis. Okay, here also same, this is principal axis, right? Now as we know, this is a center of a sphere, that's why it is called center of curvature. This is the center of a sphere, that's why this is also called center of curvature for concave, for convex. Now as it is a center, so P to C, center से surface तक, the distance between from center to the surface, this is called radius, right? So this is called radius of curvature. So this is called radius of the curvature. We know in a circle, from the center to the surface, center to the arc, the distance is called radius, right? The same thing here, from the center to the pole, this distance is called the radius of curvature, PC. PC is also denoted as R, capital R, okay, which is also called the radius of curvature. Radius of curvature. Okay, so now one thing you have to remember, that whenever any parallel rays are coming and falling on a concave mirror or convex mirror, for both cases they will meet in a particular point on the principal axis. That point lies exactly midpoint of पोल एंड सेंटर ऑफ कर्वेचर यहाँ पे होगा मिड पॉइंट में एक पॉइंट होगा जहां पे आके all the parallel rays after reflection they will meet at focus, or from this convex mirror it is appears to meet. They will not exactly meet here. Here exactly they will meet at focus. That's why this focus for concave mirror is also called real focus. In case of convex mirror, the focus is virtual because the focus is lies opposite side of the mirror, I mean the behind the mirror. So behind the mirror focus, that's why it is called virtual focus. It is in front of the mirror, that's why it is called real focus, right? So it is called focus, the midpoint of P and C. P and C, this distance, the middle point is called focus. Here also same thing, the middle point is called focus. Here also the same thing, the middle point of this is called focus. So now if this is the distance from the pole to focus is called focal length. So F, the point F is known as focus of the mirror. Focus of the mirror for both cases, this is F, right? The midpoint of the C and P, here also midpoint of the C and P is called focus. Now from P to F, that distance, the pole to focus, this distance PF, that is known as small f, that is called focal length, the length of focus, the length of focus. As I told you, this P is the reference point. All the distance has to be measured from P. Just see the R, radius of curvature, I am measuring from P to C. The focal length I am measuring from P to F. That means P is taken, pole, P means pole. Pole is taken as a reference point. From this reference point I have to measure all of these things, right? So now you can see as the F is the midpoint of C and P, and CP distance is R, radius of curvature. So this is focal length, this is radius of curvature. So this is small f is focal length, this capital R is the radius of curvature. So what is the relation between them? As F lies exactly between P and C, that means the focal length is equals to, I can say, half of the radius of curvature. Okay, or you can say the radius of curvature equals to 2 into focal length, right? So that means because the focus is exactly middle of pole and center of curvature, that's why.